Hi everyone, hope you are all doing great. I am Partharu, Events and Program Manager for Microsoft Reactor Bengaluru. And yes, I welcome you all for today's event where the topic is around develop AI agents using Azure AI Agent Service. So we have a speaker at the backstage. But before we start our today's event, let's go through our code of conduct. We all are here to learn together, participate together. So please be respectful of other people's views, understand their differences, be kind and considerate in a way we all engage. Yes, we do encourage you all to participate. Please drop all your questions in the comment section and we will pick it up from there. I would now not like to delay further and would like to bring Vikram, our speaker for today's session. Hey, hi Vikram, how are you doing?
Hey, hi Parth. I'm doing good. How are you?
All well, all great. Very excited for your session today.
Me too.
It's like every day we have so many things on AI agents and stuff going on. So, what's your plan and what's the showcase today all about?
Yeah. First of all, I would like to thank the Reactor group, Reactor team, and Parth for guiding me and having me here. And I'd like to thank all the audience who have joined. So I hope it will be a very interesting session. I've got the agenda is like I'll quickly. You want me to share my screen and start off with the agenda. So today we are going to talk about Azure AI Agent Service. What is actually Azure AI Agent Service? What are AI agents? I'll just give a brief walkthrough. I know many of us are aware of what are AI agents now. So I'll just give a walkthrough of what are AI agents and how we can create using AI Agent Service, right? And how we can create using Azure AI Foundry, which is a central place for creating, deploying, and building your AI agents or ML models. And we will go to the code walkthrough using Python SDK, how we can build from the portal using Azure AI Foundry as well as through the code. And
That's
I'll
great.
add a bit of semantic kernel also. So how to build AI agents using semantic kernel. So that will end up with the questions. So
That's
that's the
great.
agenda.
Yes, before I share your screen, Vikram, so there is some cool conversations within the community going on Azure AI over the Discord and over the Discord channel. Please go through these links. There are some great conversations going on
Okay.
AI Foundry. Yep. I'm sharing this. I'll also have a link shared in the chat as well. But yes, Vikram, I would not like to take much time. The floor is all yours. You can get started.
Okay. Thanks, Bart. Thank you all. Hi, all. Good afternoon. So this is Vikram. I hope you guys had lunch. So without any delay, we'll start off. So today the agenda is, as Parth has already said, right? We are going to have a walkthrough on how we can create AI agents using Azure AI Agent Service, both from the Foundry as well as from using Python SDK, right? So before going deep dive into our actual agenda, I just like to have a quick intro about myself. Right, this is Vikram Arigala. I'm an Azure architect. I have 15 years of experience. I started my journey with .NET. Then last 5 6 years, I have been working in and out of Azure. So my core strength is Azure, implementing, designing cloud solutions, and my my passion about learning AI and learning, learning cloud solutions implementation. Right, I have built AI driven prototypes and participated in hackathons. So I'm very passionate about technology, and I implement and I talk technology. So this is about me. uh, yeah, and you can please we can connect on LinkedIn and we can build a network and we can share our thoughts, we can share our implementation. So this is my LinkedIn handle, right? So this is about me. So yeah, so this is the agenda for today. We'll first have a brief introduction of AI agents. We'll have an overview of what is AI agent, service overview. Okay, and we'll have what are the different use cases uh, for using AI agents. Okay, when actually we use an AI agent, right? For everything, we don't need to use an agent. So some of the important things where we need to consider where AI agent can really help us with the use case. Those things also we'll discuss. We'll discuss, and I have a slide of covering the AI agent frameworks, different AI agent frameworks available in the market, right? And then we will delve into actual agenda for today, which is the AI agent service, okay? And how we can create what is Azure AI Foundry, and we'll have a demos how to create agents from the Foundry as well as using the Azure AI Foundry Python SDKs. Okay, and then finally we'll give a time for question and answers. Right, I've shared the resources in the link in the chat window. So those are the resources I have used to train, and those are the resources I have used to give the presentation. So all the demos will be covered. Whatever I have using in the demo, that will be part of those resources. I just follow Microsoft Learn documentation as well as Microsoft documentation, where they'll have GitHub repositories with all the best practices and implementation. So I take the reference from that and created the demo. So you can find it everything in those links. Okay. So let's move on. So let's start with, okay, what is an AI agent? You guys all know what is an AI agent. This is the most revolutionary technology the industry experts have been saying. uh, After, if you think from Microsoft side, after Azure or after Windows, AI agents are the most innovative things that is happening in the world, and it's changing each and every industry, right? Basically, an AI agent, is a software entity which can perform autonomously and semi-autonomously based upon user input. Sometimes it doesn't need an user input. That's where we called an autonomous. It can behave, take the inputs, and can behave and can take actions to achieve specific goals, right? So it can use tools, it can use a memory, it can use the context. So that is what, so how we use an that is how an AI agent can be described, right? So when you come to the key characteristics of an AI agent, right, one of the first characteristic is autonomous agents, right? We don't need to have a common human input for everything, right? So the AI agent can use the memory, can use the context of what the user has been asking, or the user what the user wants from these conversations, and it can use the tools, whether it has to connect to the web, or whether it has to connect to a source control, or whether we have to connect to any SaaS platform, get the data. So it can act autonomously, and it can take decisions which tool to call, okay, whether I can invoke this, whether I can invoke that function, that tool. So it can be complete autonomous. That is one of the main characteristics of AI agent. And it can be a specific goal oriented, right? For example, it can be, for example, you can say the customer AI agent, which can assist the customers with their queries, right? Or you can say, okay, I want to generate test cases for if you talk about the software SDLC lifecycle. You can say, okay, I want to create an agent that can say, okay, I can create test cases for based upon the product specification. So that is a specific, you can take it as a specific goal oriented, or it has to take an input and generate an architecture diagram. So it has a specific goal, like context awareness. So AI agents can maintain the memory and understand the context over time. So the user doesn't have to introduce every time again, and the AI agent know what the user has been asked previously, and so it can relate to the context from the conversations. It can maintain the memory, right? And it can interact through text, speech, or APIs. So basically it can connect to the external APIs by using function calling. Okay. And AI agents can work independently. Basically you can have one or multiple agents, and all the agents can collaborate together to achieve a specific task, right? So that's, we call it as a multi-agent system, right? So this is a brief about AI agents. So let's see about some of the very minimum. These are very minimum, minimum use cases. I just kept it because I just want to keep it simple, very basic, right? So if you just, now we have talked about an AI agent, it can be customer support agent, right? So when I as an I work for EY. When I as an EY employee want to know about the company policies and all, so we can create a customer support agent, right? And I can ask some questions. Okay, what is the RTO policy, right? So the agent will be smart enough to pull the data from the knowledge bases. So we'll ground the agent with the knowledge data, with our company policies and with the company documents FAQs, and so it responds to my questions and clarifies my questions. So how to raise a service no ticket, so it can get the data from different documents, right? That's the power of agents, right? So you can, this is one of the example of an agent or a coding assistant agent. You can create an agent that can review a code, give inputs, and it can even correct the code. So this is about taking an action, an agent taking an action, correction. Reviewing a code and giving recommendations is just like it reviews your code and gives recommendations. Okay, these are the things what you have changed. Then coming to an action, it can also update the code, right? Then the planning agent, basically when you have a big workflow to be done. For example, you want to do an migration using agents, right? So you cannot you can put everything in a single agent, but that is not scalable. That is not a right way to do it, right? So we can split that into multiple agents. So based upon that request, it can create multiple agents and assign the tasks to break down the complex task into simple task, and each agent will perform a specific task, right? For example, I can tell you a simple use case of, okay, I want to create a resource group, right? I want to create a resource group in Azure with uh, 5 or 6 resources. Okay, I'll tell, okay, this is the storage account I need, these are the features of storage account, these are the SKUs I need an app service, I need an RBAC to be created for app service to talk to storage account. So if you consider the use case, when the user inputs that to an agent, an AI agent can parse that, right? Can interpret that message, right? And it can, we can ask the same agent to generate the infrastructure as a code, and we can say ask the same agent to invoke the SDK or to invoke the DevOps pipeline to create that infrastructure for me, to connect, log in to Azure and deploy it, and say, okay, deployment is done. But this same thing can be split up into different agents, right? And we can, for example, the agent, first agent will be when the user input starts. The agent will take the input and it will parse the user input, understand the requirements, break down the requirements, okay, creates a JSON format. Once the JSON format is there, then we'll have another agent which gives the infrastructure as a code based upon the JSON, right? Then there is another reviewer agent which reviews the infrastructure as a code, maybe with best practices or with the web principles, what, right? So and then we can have a deploy agent that, or a DevOps agent, we can say here, that takes the bicep file or the infrastructure as a code or a Terraform file, and it deploys to Azure. So those are the kinds of very basic use cases I'm talking about. So these are some of the use cases of AI agent I just want to touch base with. And next come to, okay, when, what is a use case when we want to use an AI agent? I'll start from the bottom. If we can see interactive and goal oriented at the last, which is virtual assistant. Just we not talked about the virtual assistants in banking, healthcare. Already each and every industry is getting revolutionized with agent, right? Now all the banking, all the customer support activities for e-commerce website, for healthcare, for banking, everything is getting revolutionized and replaced with agents, virtual assistants, right? And multi-agent collaboration. If you have a very big workflow of task, right, which has to be done using different agents and have to be collaborated, have to be done, right? Where different agents are, and it is a different workflow. It goes through approvals, series of workflows. So then you can go for an AI agent, okay? Or when you want to make a decision making, or uh, autonomous vehicles or robotic systems. So those kind of things, when to go for an AI agent, right? So let's move on to the next slide. Okay. This slide will, I created to just show what are the different kinds of agentic frameworks we have. So first I have started with the Azure AI Agent Service. It is an enterprise grade a service which is provided by Azure, which is which you can say you don't have to manage the infrastructure for where the agent is running and all. You just create the AI agent service, and then Azure will take care of the infrastructure that is required to run, build, and deploy that AI agent. And AI agent service is used for creating single agents, not it's not a multi-agent framework, right? LangChain, you can, there is a different there is another framework where you can create LLM based applications with agent capabilities. And Semantic Kernel. Semantic kernel basically is it's also a framework which is used for orchestrating it. Semantic kernel also, you can create single agents as well as multi-agent orchestration can be used, can be created using semantic kernel, and it is rich in plugins. And since it is an Azure framework, it is tightly integrated with Azure. So semantic kernel is one framework where we can use Autogen, for building multi-agent conversational systems. We use Autogen, but semantic kernel is production ready. So basically, whatever we develop in Autogen, we are converting that to semantic kernel to deploy it on client machines. And Autogen is basically you use to research your idea, build a multi-agent system, right? So this is also multi-agent framework. Crew AI is another kind of framework, and LangGraph. LangGraph is also a very widely used multi-agent orchestration framework. So these are the some of the frameworks which I have highlighted. There are more. I just for the sake of the slide, I couldn't fit it everything, so I just limited to few. Okay, moving on to the next one. Okay, so now coming to the Azure AI Agent Service. Just now we have spoke about Azure AI Agent Service. It is a fully managed service, right? Which is managed by Azure. We don't have to worry about the compute and the storage resources required to run an agent. We create an agent using Azure AI Agent Service and deploy it in Azure, and we and it takes care of managing infrastructure and compute resources, right? And Azure AI Agent Service is powerful because it is integrated with Azure AD. We can use managed identities, we can use Azure rollback taxes, rbacks, right? And it has tools inbuilt, like you can use a Bing search, you can ground your agent with a Bing search. You can use there is an inbuilt code interpreter tool which can generate the code and generate graphs for you, right? And you can use tools like you can ground your agent with Azure agents, Azure AI search service, which is used for RAG applications. And you can even integrate with Azure functions and logic apps also. As of now, we have Azure functions where you can integrate with Azure AI agent service, right? And you don't have to we all have heard about tools which makes AI agent which makes AI applications powerful, so that they can interact with the external systems, external APIs, and perform actions, right? So here there is an automatic tool calling. You don't have to create a function in such a way that LLM application will understand, and you have to parse the response. That is handled by the framework itself, Azure Agent Service, right? And we have and in Azure Agent Service, the data is managed securely. The context is memorized using the threads. The threads are nothing but an instance. It's a conversation between the user as and an LLM application. So you don't have to manually store the context. It can persist the conversation, and it can respond to the following user questions, right? We will see that in in the demo sessions, right? And as I've told previously, we have out-of-box tools like Bring, Azure AI Search, and Azure Functions for effortless data interaction, right? So before going this, so we might have a confusion, right? Now we can create AI agents using Azure AI Agent Service, and you can create using semantic kernel, or you can use LangChain. What is the what is the difference, right? Azure AI Agent Service is since it is managed by Azure, it is a fully managed service, and it is tightly integrated with enterprise Azure capabilities like security. You can say networking, you can implement private networking, and it has its own. You can create your own storage account, so uh, you can create shared or like specific storage account for your resources when the processing happens, so it can store the data. So it is integrated, it is an enterprise Azure service. So that is a difference I can say. And it has one of the rich features is the tools what we have inbuilt. Think like you have to ground your application with Bing search. How much code we have to write, right? And that is handled. There is a connector. You just have to call that tool and add it to an agent, and then invoke it. Then it goes to the Bing and searches query and gets your data. So, and you can even integrate with Azure Functions, and you can ground with Azure AI Search. It is tightly integrated with Azure, right? So that is the main difference I can say. And yeah, let's talk about Azure AI Foundry a bit. Uh, uh, Previously, we used to have Azure OpenAI service before Azure AI Foundry was there. We used to create an Azure OpenAI resource, and then we used to create LLM application. We used to invoke it, right? Then Azure AI Foundry is like a unified platform where you can build your AI applications, as well as you can, if you want to build ML models, you can, you want to develop ML models, develop, build, deploy agents, ML models. Azure AI Foundry is one place, right? So you can build a workflow, you can create ML models, build, deploy, test. So it's a complete life cycle management of your application development is handled in Azure AI Foundry. It's one place where you can do, where you can build your enterprise level AI applications. Simply put, that is a Azure AI Foundry. Okay, so let's move on to the next slide. Yeah. Before moving on to the next slide, I'll just walk through Azure AI Foundry, right? Uh, what is actually Azure AI Foundry, how it looks. I know many of you have already started exploring Azure AI Foundry, but I just want to walk through a bit of how it looks, how to create a hub, what is project, how we can create AI agents and invoke them in the playground before going into the code part, right? So let me just uh, I hope my screen is visible, right? So yeah, so please let me know if my screen is not visible. I'm just sharing it. You should see my Azure portal screen. Okay. So I've created this resource group uh, for this demo. So basically, you can see if you go to Azure and type Azure AI Foundry, right? So you can create a hub, and then inside the hub, you can create a project where your entire team can collaborate and collaborate on that project. So hub is nothing but a container for different kinds of project, right? So basically, for all your projects, your compute management, security, connectivity, everything will be managed in the hub. So basically, you'll first start with creating a hub, and then once the hub is created, you click on next review create. Once the hub is created, right, then see, this is the hub I have created, so I'll launch it. So just click on that hub, and we will, yeah, launch the Azure AI Foundry. So this is how you, after creating a hub, you will launch an Azure AI Foundry, and you can see what are the, you can create projects under this. So I've already created a couple of projects. You can create always a new project, right? So when you click on new project, it will ask for your project name and what is the hub you wanted to use. So we'll go to the Azure AI Foundry. Sorry for the disturbance, guys. I think there is some network glitch. Okay, so this is where you create a project. I've already created a project here. So when you say select a new project, it will ask what is the hub you want to create under, and then you click on create. A project will be created. Since I've already created a project, I'm not doing it now. Okay, so now this is the project. For example, if you consider this project, just click on this project, right, and go to models and deployments. See, I've already deployed a couple of models. So you can deploy a model. Once you select that base model, whatever you want to create, click on confirm, and that the model will be created, right? So I've created two models for two different purposes. Why I've created two models is, uh, I'll show the reason for creating the two models. I'm not using, for example, if you want to use a Bing, if you want to use a Bing search feature, right? You cannot use it with a mini model. It has, so mini models, GPT-4 or mini doesn't support Bing search, and so for those kind of requirements, I have created two models. Okay, and we go to connector resources. resources here, it will show what are the Azure OpenAI services that were connected to this resource. So there is an Azure OpenAI service, there is an Azure AI service that got connected, right? So now, so let's go to project and see here is the feature. So if you observe this project, so this is the OpenAI service endpoint which you'll be using, and this is the key, the project connection string. So this is what is required when when you're using a SDKs from code, right? You have to establish a connection to this project. Once you create a project, then you have to take this connection string, create an instance of an AI project using the Azure AI SDKs, then pass the connection string so that the connection will be established. Then you can create agents using the code. Okay. So this project connection string is very important. Right. Now, this is a section where you can build your agent from the UI, and then you can that's it, right? So I'll create an agent. I'll say I'll select this. See, already I've created many agents. So if you see this agent, right, I'll click on this agent. I'll say try in the playground. Okay. So if you see here in the agent setup, correct, there is a section where you can add a knowledge and you can add an action. In the add a knowledge, you can see the option. You can upload a local file and you can query, and you can keep on querying about. You can ask questions about that file, and you can ground with Azure AI search for RAG things. I think you can also connect with Microsoft Fabric, right? See, grounding with Bing search. This is what I've talked about previously, but this is not compatible with the enterprise subscription of Azure, I believe. So that's why I'm not able to do. You can connect with all other external things. So this is how we can add a knowledge to an agent, right? And if you scroll a little bit down here, this is where you can add an action. So you can see, you can, I've already enabled code interpreter, so we'll see it in action. You can also uh, add an action to invoke an OpenAI spec. You can upload an OpenAI spec, and you can invoke uh, APIs using OpenAI spec. You can even call Azure functions, or you can invoke any APIs using custom webhook. See, it is clearly mentioned you can invoke Azure function and custom action only through the code. Now we are just going through how to create an agent and test it from Azure AI Foundry, right? So, okay. So I've got some of the prompts ready. So since I've used a code interpreter agent, right? So I've already given the code interpreter agent to Azure AI agent service. Now I'm asking a question to the agent like, okay, use the code to determine the values in the Fibonacci series that are less than 101, right? So we can see the threads, the conversations that is happening, how the Azure AI agent service uh, uses the code interpreter tool, because we are providing the tool. Just now we have talked about the power of tools, right, which make AI agents powerful. So we have given the code interpreter tool. So using this code, it has calculated the Fibonacci series, and then it has written the results. See here, it has also shown you the code interpreter response. So if I copy it to the notepad, we'll see the code what it got generated, right? This is simple code. So I have passed the values one on one. So using this code, it has generated, right? So this is how we can create agents, and you can see how many tokens that have been used. So this is how you test from the Azure OpenAI, Azure AI Foundry. Okay, uh, and we can try one more. Uh, yeah, right. So I'm asking to create a bar chart with the following data, right? how we don't run into token issue. So you can see it has generated a chart for us using the data what we have provided, right? So these are like this is how you create an agent, test it out, right? So now once your agents are ready, for example, you have an AI agent that connects to Bing search, get the data, and you have another agent that calls an Azure function to create a resource in Azure, right? So you can combine these two agents using a framework semantic kernel, and then you can combine these agents, orchestrate these agents so that it completes the task for you, right? So Azure, this is how we create. I mean, I wanted to say single agents using Azure AI Foundry, right? So this is brief about Azure AI Foundry, and uh, it has so many features. Uh, Considering the time, I don't want to delve into all the features because each and every feature we have, it will let minimum take 5 minutes to walk through. So right, so we'll move on to the next slide. We'll go to the code part, right? So now we'll see Azure AI Foundry SDK, right? Using Azure AI Foundry SDK, we can create AI agents using Azure AI Agent Service, right? From the code. So I'm as part of our demo, we'll be using Python. You can use C Sharp also, but I prefer doing things in Python when it comes to AI, so always go for Python. And you can see all the Microsoft frameworks strongly have examples and support for la- Python language also, right? So if you can the prerequisites for the demo, right? So these are the two main pip packages you need: Azure AI projects and Azure identity, because we authenticate to Azure initially before going to the demo. And the Azure AI Foundry, I have shown you the project connection string, what is the importance of it. So we create an instance of an AI project, so how it authenticates. So these two libraries are one of the key important libraries. Of course, you need Python installed on your machine, right? Next, we'll go on to the uh, demo part, right? This will be interesting, and this will be more interesting because uh, the interest comes when we actually do the code, not from the UI, right? So now, as part of this demo, I'll share my VS Code, and I have created some examples how we can create AI agents using Azure AI Agent Service, as well as how we can create AI agents using Semantic Kernel, right? So that, and we'll see an example of multi-agent uh, chat, how different agents that can communicate each other that were created using Azure AI Agent Service. As I've said earlier, Azure AI Agent Service is to create standalone agents. Then if you want, you can create a number of standalone agents, and then you can orchestrate them using multi-agent framework like Autogen Semantic Kernel, right? Let's quickly move on to this demo. So as part of this demo, I I just want you walk through to the structure. So basically, I've created a virtual environment so that it won't disturb the existing Python libraries I have. So I've created this folder environment, virtual environment, just for this demo sake. So you can see the requirements.txt. These are what I have used for this demo. Okay, and first I'll walk through the environment. Okay, this is the project connection string, which I have shown you previously, which is important to create an Azure AI service, right? And now we'll quickly start off with the uh, code interpreter demo. So the same thing which we have used previously, we'll be doing the same here. Like I have asked the question to identify, right? For example, you can see the code interpreter agent. I said, okay, create a bar chart for the operating profit using the following data and provide the file to me, right? So this is the same thing which we have seen using code interpreter tool. Now we'll see, we have done it from Azure AI Foundry. from the UI. Now we'll see how to do that from the code, right? So you can see here, yeah, I will zoom in a bit. Yeah. So if you can see, these are the, this is the project client that is very important, which is used to instantiate the project we have created in the Azure AI Foundry, right? Then we authenticate, since the agents will be running in Azure, we authenticate. The authentication happens through managed identities. You should have your proper roles assigned, Azure AI contributor developer roles assigned at the subscription level. You should be you should be an owner at the subscription, so those kind of things, right? And yeah, if I can scroll a bit. So see, first we create an instance of a project client, right? We pass the credential because I've already authenticated myself using AZ login, Azure CLI command. So I am the owner of this subscription, Enterprise Visual Studio Enterprise subscription. So I'll have full permissions to connect and talk to the resources. So that's where the authentication, we are using the default Azure credential, right? So, uh, so once the project is instantiated, then we'll create an instance of the code interpreter tool. And this is important part where we create an agent and we pass the code interpreter tool to the agent, so that we are asking the agent to use this tool to give an answer to the user request, right? And then we create a thread. As we discussed previously, thread is uh, useful for maintaining the state and the context between conversations between the user and the LLM application. So you create a thread, and then the thread will be passed to create a message. Whatever message we have created, you can see I'm asking, this is the message I will be asking. I create a bar chart for the operating profit for these companies, right? Then the next step is we'll run the agent, right? Once we run the agent, then we'll list down the messages. Okay. So this code is the following code. The important steps I wanted to show is how you create an instance, how you instantiate code interpreter tool, how you create a project client, because these are very important for your code to work. Okay, let's quickly run this. See, you can see the conversations. It is happening. So you can see the thread here. I've asked the question, could you raise a graph chart for me? And then you can see the assistant replying, I have created a bar chart, and then you can download it at the link below. So it has generated a PNG image with the bar chart. So this is the same which we have seen previously, right? So this is how you do with a code. So now we'll see another example where we'll do a file search. So basically, this is an MD file. I have, for example, it is about an eyewear, okay, and what features that eyewear provide. It is a very basic file, but the idea for showing the files, how we can use a file search feature, right? Using an Azure AI agent service, right? So you can see here, uh, this step is common, right? We'll create a project client, then we upload the file. Then once we upload the file, we are given the file path here, this one. And then what the framework will do is it will create a vector store, which is nothing but an object store to store that file. and then we create a file search tool which will pass the vector store IDs to it. Then we pass this tool to when we are creating an agent, right? How we pass the code interpreter tool. Let's quickly run this and we'll see. Basically, I've asked a question: what feature does Smart Eyewear offer? So it will read that file, it will do a search, and it will return the response. So this is a basic functionality of a file search, what we can do using Azure AI Search Service. And you can see I have printed this last message which was done by the assistant. So it says it has augmented reality interface, voice controlled AI assistant. So basically, these are the features. It has, yeah, augmented reality interface, voice controlled AI. So these features it has read and printed out. Okay, and we'll quickly see now how we call an OpenAI spec. Basically, uh, this is where this is the server where from where the weather data will be. We can retrieve the current weather data based upon the, we can pass the location, right? And then it returns the weather response, right? So this is an OpenAI spec. So using this OpenAI spec, how we can call the APIs and get the weather, right? So the common steps are project client, that is common, right? And yeah, here comes the step for the OpenAI. So we parse the JSON, we'll open, we'll read the spec. Here we are using anonymous authentication. Then we'll create an then we'll instantiate the OpenAI tool, and then we pass the tool to while creating the agent, right? So I will quickly run this and I will show. So you can see the instructions while creating an agent. You are a weather bot, and we are clearly saying use the provided functions to help answer the questions. And we are passing the OpenAI dot definitions to the tools. So previously we have passed code interpreter tool like file search tool. Now we are passing the OpenAI spec tool, which we created here, right? And then our question will be what's the weather in Bangalore, right? So it goes to the server, pass the parameter and get the data and returns a response to us. Let's quickly run this and see. I think this should be accurate. Uh, Actually, it is like feeling hot today. So this is how you can invoke. So it returned all the details from that server, from that API, right? What are the parameters it returns? So this is how we invoke an OpenAI service. So these are the different tools which you can provide to an Azure AI agent service and make the agent powerful, right? So and I have also created some of the examples using semantic kernel, how we can create those agents, right? So we'll quickly see what has been done. I'll just show two examples, I think, based on the time constraint, right? So if you can see the important, uh, you can see the imports or that are required to create a Azure AI agents using semantic kernel. So this is where the namespace, you can say, where we'll create an using the Azure AI agent. So you might have already known we have a chat completion agent, OpenAI assistant, and this is Azure AI agent. So we are seeing using semantic kernel how we create different Azure AI agents, and we'll see how we can create a group chat agent also. Okay, so this is basically, I have a plugin which has two methods, okay, which has like, okay, what are the specials for today? There is a These are the three types of specials, and we have a hard coded price that returns for each uh, menu, right? So these are the user inputs that we'll be using for this demo. See what the user will be asking, okay, what is the special soup today and how much that is got. So we'll see how we can achieve this using semantic kernel. Okay. So you can see this is the, so this part creates an agent using Azure AI agent service. See the client is that we will create an agent, and the credentials are nothing but, if you go here, so it should be in this format. So these two are important to create your instantiate your project client from the semantic kernel. You need a project connection string, which we use. This one we used it for Azure agent service. These keys we are using for semantic kernel. Okay, so this is a project connection string, and I'm using the deployment as GPT-4. Okay, so when we instantiate create client, right? When we instantiate create client, it looks for the keys. It looks for the keys in the environment file. See that this is the Azure AI setting. So this is required. Okay, so without this it won't work. So this Azure AI settings, it will load from, see, the environment file path. If you don't provide that, this Azure AI settings will fail, right? Then you create an agent, and then we'll run this and see how it works in real time. As you can see here, in the loop of the user inputs, now when we ask for what is the special soup, it uses that plugin which we have provided to get the soup. Then the next question, follow-up question, will be how much does that cost, right? So now it is again using the plugin. So this is uh, so this so this ends the conversation. So this is a conversation between a user and an AI agent. How we asking about a menu and then the price in the menu, right? Now till now we have seen so the power, if you have known about semantic kernel, uh, semantic kernel, one of the main features are plugins, right, where you can provide different functions, and the semantic kernel default, it calls the function behavior based upon the query. So here we didn't even specify what function it has to call. So based upon the user input, it calls the specific function and returns the response to us. So that is one of the main features of semantic kernel. Now till now we have seen single agents how we create. Now now we'll see a single group chat. We'll create different AI agents, and we'll see how the AI agent as part of this example, it is a simple example. There is another example which is bit uh, not say complex, which has more features, but this is pretty simple. So this example has two features, two agents. One is a copywriter agent and the reviewer agent. Basically you will pass and you will ask the agent to generate a copy, to generate a tagline for your new ice cream shop, or a new bakery, or a new uh, shop what you are opening, right? Then it creates a tagline, then the tagline will be passed to the reviewer agent, and the reviewer agent will tell, okay, if it is good or bad. Then it again sends back to the copywriter agent, it again rewrites it and sends. So this is how uh, and two agent communication here. I'm saying two agents specifically because I'm using two agents here, right? So this example has two agents. So we'll see briefly about and then we'll run the code. I think we have eight more minutes. I just need to leave 5 minutes for the questions. So with this example, I will end my presentation. Just give me a moment, right? So if you can see, these are the instructions. This is one of the agent behavior. Okay, this is how we define an instruction. Say, okay, you are an art director, you write copyrights about, right? Then you are an copywriter, right? uh, then the copywriter will write, and art director will review about what copywriter has written, and it gives a response, right? So we are just asking, okay, give me a slogan for a new line of electrical cars. Okay, now we'll see how the agents know how it has to communicate, right? So you can see I create an agent using Azure AI agent service. This is the reviewer agent, right? And then this is the writer agent, right? And then we instantiate a group chat. This is what we have discussed about multi-agent collaboration. How these two agents will collaborate in tandem, right, to achieve the task. Because a writer will write, it gives to the reviewer, reviewer will review, and it gives the comments to the writer. Writer will again write it until the reviewer says, okay, it is good, right? So, and in semantic kernel, when you're having a agent group chat, you can specify what I can say is an approval strategy and a selection strategy and a termination strategy, right? I will just show the selection strategy and the approval termination strategy. See, this is when the approval, when the agent conversation will terminate. If you don't specify the strategy, the conversations will go on infinitely, right? We're telling, okay, if the agent says it is approved, then stop. The conversation has to stop, right? So this is how we specify. And once it is approved, right, we pass to the agent group chat, and we have a termination strategy here. Like, see, in the termination strategy, we have approver equal to agent reviewer. Once the reviewer says approver, just the conversation ends, and we are saying maximum iterations has run so that it won't go to infinite loop. Okay, so we'll quickly run this and see how it works in real time. How the And I'm going to print the agent conversation also to this command window so that it will be clear. We'll just wait for 1 more minute, and if it is not executing, I'll skip this and we'll move on to I have one more slide for resources. I've already shared that in the chat, and we'll go for Q&A. Yeah. So now the interaction has started. So the user question, then copywriter has the writer has given some thing, and our director say, okay, it is approved, right? So that's end the conversation. So basically, now we can see how the copywriter agent is a single agent which is created by Azure, and the art director is also an agent which is created by Azure Agent Service. And we created a group chat and made it an multi-agent system where the two agents will interact and give a nice slogan to their users for their ask, right? So you can see once it is say the art director says it is approved, the conversation got stopped, because in the approval strategy we have said if it is says approved, then it should terminate, right? And you can see we have passed the approval termination strategy here from the agent reviewer. If it says approved, then you can go ahead and stop the conversation. Okay, so yeah, that's in my presentation. uh, any questions? I have one slide for best practices. um, uh, Now we can have a storage account in our Azure, which the Azure agent service will read, scan the files in the storage account, and gives recommendations. For example, you can have log files in your storage account, and your Azure agent service can search the log files, read the errors, and provide recommendations and even fix, right? So how you connect from your Azure agent service to storage account? So since it is tightly integrated with Azure, since it's an Azure managed service, so use rollback access. And we can use even I think there's a new features in coming up in Azure agent service. You can use application insights for tracing and logging. right? And you always use keyless authentication. Here we are using managed identity and role-based access for authentication. So these are some of the best practices. And yeah, uh, any questions, Parth? Do we see any questions?
Yes, so we have a question from Earthman. He's asking like if we used an AI agent with knowledge, can this be considered as a RAG? What is the difference?
Yes, yes. That's a RAG agent basically.
Okay, so Yukesh has a question again. Why can't we have one agent doing all of this?
That is what that I mean. That's a good question, right? So basically, you we are thinking about small use. Think about a very big use case where you put everything in a single agent and you cannot scale it properly, correct? And you need to have a specific instructions for specific agent. That's where the multi agents comes into picture. If you have everything in one agent, you have to do everything with the plugin. For example, you have a very you're doing an Azure cloud migration. Think like using agent. How many steps you need for a cloud migration? We need discovery assessment. We need to create a business case. Okay, we need to do pre-migration, migration. All these activities, if you put it in a single agent, how it looks, it you cannot scale, you cannot trace if something fails. And that's why we have to break the complexity into multiple agents and assign specific tasks to each agent. Okay, one agent will review, one agent will parse, one agent will generate the code, one agent will deploy the code, one agent will review the code. So that's how you scale and make your application scalable. And you split the code across multiple agents, and you can have multi-agent collaboration so that you can trace and you can implement the workflow, right? uh, that's why the best practice is not to, you can use single agent if it is simple use case, right? If it requires approvals, because yeah, all the things we cannot do without manual approval, right? Sometimes you need approval, sometimes it has to call different tools, different APIs, it has to interact with different SaaS platform, different platforms to get the data. That case you cannot put everything into a single agent, because that is not you cannot that is not a right practice, right? So it depends upon the use case. So I hope that answers the question.
Yep. So there is another question from Pallavi. She has like, please show how to connect each agent and publish in public.
Publish in public in the sense how you deploy, does it? Yeah, basically we are running it locally, right? So for example, if you consider this use case, this how you generally deploy an A agent, right? You for example, take this use case of a file search, right? Basically I'm running it locally. Now you can create a fast API out of this, right? And you can deploy this, you can containerize it and deploy as a container and deploy it as an app service. Okay, and you can have these multi agents here. This entire application, you can deploy it to an app service, and then you can create a function out of it and it can call it from UI. So uh, you can deploy it in many ways. So the best how we are doing as of now in our organization as well as is we create agents and we deploy it to an app service so that they uh, you can easily call from an API. And you can use different protocols. Now we have different protocols like basically you can use an MCP servers now to integrate with different tools and APIs and provide the context. So yeah, I hope
Okay.
that answers the question.
Yeah.
Yeah.
So Yukesh has a question again. Like how to pass the agent to public, how to integrate it basically. I think it's a similar thing, right? Yes, I think yes.
Yeah. Yes. I mean, how you pass the agent to public means how we can invoke an agent externally. That's I'm thinking in that way. If that is the thing, just now we have discussed, like we have to deploy this uh, as an API and then invoke it basically. That's how we basically do. You can create as an app service, you can deploy to a Kubernetes, you can deploy to container instance, or you can deploy to a function app and a HTTP trigger. If it is a chat band of application, you won't use HTTP, right? So you will use a different protocol for it. If you have a complete chat kind of an interface. So if you have an agent that calls an Azure DevOps pipeline, basically you create an API out of it, deploy it as an app service, then you call that from an interface. You call that an API from an interface. So it does that task. So
So another
yeah,
question from Manoj asking, how do you pass the chat history back to the agent and where can we store it?
chat history is basically whenever you are coming. As just now I've explained the uh, threads, right? So thread stores the context, and whenever the agent gives the response, you can create a chat history object, and then add it add it to an array, basically, right? Then the chat history will be preserved. You can preserve the chat history either in memory, or you can store it in Azure Cosmos DB and retrieve based upon the user inputs. The best place I think to store the chat history is I think Cosmos DB, because in the examples you can see we have a minimal chat history. That won't be the case when you create an enterprise based application, right? It has to be tied to an user, because when I come in today and I ask some few questions to an assistant, right, it responds. Next time I come, I log in the next day, my session should persist and it should know whatever I've asked previously. So basically the storage of chat history should be in a like a no unstructured data, and it should be stored in like Cosmos DB is the best place to store. Even we can vectorize it.
Okay, I hope that answers the question. One last
Yeah.
question, Vikram. It's from Ankit. Like, how do we test the agents that we create from the code and automate it?
Yeah, testing part, I'm not really sure. That's a good question. I mean, that's the part I never really explored it. Sorry, I don't have really an answer for that. The only way I think is I can tell is like we first you how we used to do is we test it from the playground floors. Once everything is working, then we'll come to the code, integrate it, then we'll use the usual testing approach. I mean, I don't know any of the frameworks which can test the agentic pattern now. I'm not sure.
Okay, we have a few more questions coming up. If you are up, we can take it up.
Yeah, sure. I can take for a couple more minutes. Uh,
Okay, so Junior has a question like, what role MCP can play to store chat history?
uh, Sorry, ask that question again. What role MCP can store?
What
Okay, base.
role?
Yeah, okay, understood. See, basically, MCP is uh, is a kind of a, you can say, a framework or a service, right, which exposes, which provides the context to your LLMs or the agents, and you can easily integrate your uh, tools with the LLMs. So you'll have a standard protocol so that you can invoke the tools. What role MCP plays for storing for the context? You don't have to store the context separately. MCP server will take care of it, so you don't have to worry about storing the context when you uh, have multi-agent collaboration, because you will have an MCP server, you will have an MCP client, right? Your MCP client will be your interface or an agent code or a code that calls the MCP server for, if it has to call a tool, or if it has to call GitHub, or if it has to do some other action, it calls the MCP based server, and it gets the data and it stores the context. It preserves the context for each conversation. Hope that answers this question.
Okay,
but I
and
have
one last
one more
question.
minute. Yeah, please. Yes,
So
Parth,
he was
please.
asked, like his client is asking to explore on using a Copilot or AI agents to trigger DevOps automation scripts, monitor
uh,
and create alerts in success or the case of success or failure. Can this be achieved using AI
yeah, yeah.
agent?
Yes, yes, yes. I mean, this is one some of the use cases what in our organization we are doing. Uh, uh, Basically, if you're, I heard he is asking about invoking DevOps pipeline. Am I correct? Right? In one of the requirement. Yeah, I mean you can do that using Azure AI agent. So that's we have seen. You can integrate. You can call OpenAIs and you can use webhooks to invoke logic apps, and you can even have the DevOps. You when you create a DevOps pipeline, it will have the URL, right? You can use that, create a plugin out of it, and say and pass it to the semantic kernel. And when the agent gets invoked, you can say, okay, use this plugin to invoke a DevOps pipeline. You create an agent out of it, and then you can use to call in DevOps pipeline. And you can, uh, for example, you have a log files. You're talking about the log files. You have it in a storage account, right? All the logs. So you can have a process. Like, for example, a logic app that reads each file and sends an API call. That it's basically it need not be always chat based, correct? An agent need not be always a chat based interaction. It can be backend as well. You have a log files, you have to get the error messages out of it, and if there is any error you can send an alert. So this can be achieved using some of the agents. For example, you have a parser agent which takes the log file, parses, takes the errors out of it, reads the errors, categorize the errors based upon the hierarchy. That is a different agent. And once the hierarchy categories basically categorized based upon high critical and severity, and you can have another agent based upon the severity, call an Azure monitor API to create an alert. You can do that. That can be also a plugin. We can create it as a plugin, and we can pass it to an agent. That is doable.
Yes, so thank you. I hope all your questions are answered. If you have many more questions, you can reach out to Vikram. I'm pasting his LinkedIn account here. Please feel free to connect him. And yes, Vikram, thank you so much for uh, your session today. And thank you everyone for joining us today. Hope you all
Hey,
had a
thanks.
great time. And we shall plan another event soon.
Yep.
Thank you
Thanks,
so
Parth.
much.
Thank you, everyone. Thank you for having me today.